Welcome. We got part 6 of general equilibrium models of money. Here, what we are going to be doing is going a little bit further into monetary neutrality. So from the last lecture, right, I went through the Euler equation. I was talking about how steady state values of capital are unaffected by changes to the money supply, either in changes to the growth rate or to the stock of money, right? So I kind of went through this, right? In the last presentation, I said consumption would only be constant when the marginal product of capital less depreciation is equal to 1 over beta. Remember, 1 over beta is that 1 plus rho. So really, when the marginal product of capital less depreciation is equal to how impatient you are, consumption will be constant. Why? Well, if the marginal product of capital less depreciation is basically the value you're getting, the marginal benefit of saving an additional dollar, that 1 plus rho would be the marginal cost of saving an additional dollar. So when the marginal benefit of saving a dollar is equal to the marginal cost of saving a dollar, then you are kind of at like this break-even point. And when you have that break-even point, you are going to have constant consumption, because if you save a dollar today, right, you get that dollar back plus a little bit more tomorrow. That break-even point, this is saying that consumption is going to be constant. It's neither growing nor declining. So if there's an increase in the growth rate of money, right, which would thus increase the rate of inflation, if that were to actually induce households to accumulate more capital, KT plus 1 would increase. It would lower the marginal product of capital, as I said before, and we would have a situation where we are now more impatient than the market is able to compensate us for saving an additional dollar today. And so we would essentially have households wanting their consumption paths to decline over time, which means they increase their current consumption and future consumption falls, thus reducing their holdings of capital. Because of that, right, steady state capital is independent of the rate of inflation. Now, another way that I can say that, maybe in slightly better English, would be the money stock were to affect steady state capital. Households would want to hold more capital. KT plus 1 would increase, CT would fall. The marginal product of capital, right, how much more output we get from one additional unit of capital, falls. Because remember, if you increase capital, the marginal product of capital will fall. So we'd become more impatient than what the market would reward us for saving. And if we are more impatient than what the market is able to reward us for saving, we aren't going to be saving as much, which means that we consume more today than we are tomorrow, and the consumption path declines over time. It will decline over time until this marginal product of capital less depreciation becomes equal to 1 plus rho, or 1 over beta, right? Because remember, 1 over beta is equal to 1 plus rho, which made a little boo-boo here. There's supposed to be an equal sign right where I've got this little cursor. 1 plus rho is supposed to be equal to the marginal product of capital less depreciation. So my bad on that part. So basically, changes in the money supply won't be affecting steady state values of real economic variables. And if it's not going to affect the capital stock, it won't directly affect output. Because output, remember, has capital as an input. So if it's not affecting capital, and capital's the only input in the output function, then output isn't going to be affected if capital isn't affected. So there are really two reasons why this particular model would have monetary neutrality. 1, markets are perfectly competitive, and 2, prices are flexible. Now, the flexibility of prices really kind of relies on the first reason, because if you've got perfectly competitive markets, but you have prices that aren't flexible, you can kind of run into some problems. But what this means is that if there were a demand shock of any sort, prices are completely responsive to the shock, and output doesn't change at all. So you have a vertical aggregate supply curve in price and output space, right? Now you got your downward sloping aggregate demand. So if you think about aggregate demand, right, it's just, you think of it like a demand function, right? So aggregate demand is downward sloping, but we've got a vertical aggregate supply, which means that there's kind of like this long run rate of output, or this flexible price output, y sub f, that we see here. That flexible price output, because it's flexible price, means that it's independent of prices. It's independent of the change in prices. So if I've got inflation here and I've got output as my vertical and horizontal axes, and I've got aggregate demand and aggregate supply, that equilibrium exists when I've got an inflation rate of pi t superscript 1 at the flexible price output y sub f. Now, if there's a demand shock, if aggregate demand were to increase, well, with a vertical aggregate supply curve, because it's independent of prices, right? There's not going to be this upward sloping aggregate supply curve. It's just vertical. When we have that, all that happens in response to a demand shock is an increase in prices, and output itself doesn't change. So can we see why a change in the money stock would have no effect? Yeah, why not? Consider we've got real money balances, not nominal. So if there were an increase in the nominal stock of money, prices immediately respond. So there's no change to the real stock of money, right? So the real stock of money, in equation 2 here, is equal to capital M, or the nominal stock of money, divided by the price level. But if the price level responds immediately, given an immediate change in the stock of money, well, M would increase by the same amount that prices would increase. If M goes up 5%, right, prices would go up by 5%. So by whatever amount you increase the nominal money stock, the price level increases by the exact same amount. Thus, the real stock of money remains unaffected. So what is affected by money growth if inflation is going to immediately respond? Well, anything that pays off in a unit of money at some future point will be affected, right? So if it's going to have, say, a nominal, like a positive nominal return, well, if it pays off in units of money, then you could have something where the real rate of return would be affected. So the real value of those future units of money are going to be affected by inflation. And it's reflected in the interest rate that's required to induce people to hold the asset. What do I mean by that? Well, think about a nominal interest rate that an asset has to give in order to produce a real return of, say, R in terms of consumption goods, right? So think about an asset that costs 1 unit of consumption in period T. It's going to have to yield 1 plus R units of consumption in period T plus 1. Now, in units of money, this asset's going to cost P units of money at time T. Since the cost of each unit of consumption in period T plus 1 is going to be PT plus 1 in terms of money, the asset has to pay an amount that's equal to 1 plus R times PT plus 1. So the nominal return is going to be 1 plus R times PT plus 1 minus PT over PT. And that gives me 1 plus the real rate times 1 plus the future rate of inflation minus 1 equals the nominal rate of interest. Now, equation 3 could look a little strange, but it's really just the Fisher equation, right? So when we get into the next slide, you'll see it's just the Fisher equation. So what is affected by inflation? Well, any asset that pays off in units of money at some future point is going to be affected by inflation. So with this nominal return that we saw in the previous slide, right, the Fisher equation, in the steady state, what it means is that 1 plus the real interest rate is going to be equal to 1 over beta. Now, you're probably going like, oh, God, there's a lot of math here. And, I'm not going to lie, there is a lot of math, right? But remember, 1 plus the real interest rate is equal to the marginal product of capital less depreciation. So the left-hand side of equation 5 is just equal to the marginal product of capital less depreciation. And that's equal to 1 over beta, which we've gone over in this slide in this presentation as well as the previous presentation. So the marginal product of capital less depreciation is equal to 1 plus the real interest rate, and that's equal to 1 over beta, or it's just equal to 1 plus rho. Now with, say, pi sub SS being the steady state rate of inflation, the steady state nominal interest rate is going to be equal to this right here. 1 plus steady state inflation divided by beta minus 1. And the interesting thing here, right, is it varies 1 for 1 with inflation. And in case you're wondering how I got that, right, look at equation 4 and equation 5, and I just did a little bit of algebra, sub some stuff in there. You don't need to worry how I got it, because I'm not going to make you derive this. But what you do need to know is that in the steady state, the nominal interest rate is equal to 1 plus pi ss over beta minus 1. And because it is equal to what it is in equation 6, the nominal interest rate varies 1 for 1 with inflation. And if the nominal interest rate is varying 1 for 1 with inflation, say inflation increases by 1%, the nominal interest rate increases by 1%, and the real rate remains entirely unaffected. So with the nominal interest rate, right, equation 7, just like what we saw here in equation 6, it's the same thing. With it varying 1 for 1 with inflation, it means that from the Fisher equation, which is nominal being the sum of the real rate plus the rate of inflation, any change to inflation leads to an equal change in the nominal interest rate, which means if you were to change the inflation rate by changing the money growth, or say the change in the money stock, right, a one-time change in the money stock, you aren't affecting the real interest rate at all. And since changes to inflation will lead, changes to the money stock will lead to changes in inflation of the same amount, the nominal rate basically picks up all the slack and the real rate doesn't change at all. And because the nominal rate responds fully to a change in inflation, and there's no ability for the real rate to move whatsoever, we have monetary neutrality. Because if that real rate were to change, if there were some ability and the real interest rate to change, given some change in the money growth or change in the money stock, right, that would transmit into the real economy via the real interest rate. But it's not. So because it's not, only nominal variables are affected, real variables are not affected. Thus, we have monetary neutrality. And that is going to wrap up this lecture. There is one more lecture coming where we completely wrap up this stuff and we go over the welfare costs of inflation. But I figure, I want to kind of break these lectures up a little bit into more digestible lengths of time. So thank you for watching this one. There's one more lecture coming, and that will be wrapping up general equilibrium models of money. Thank you for watching. Peace out.